Welcome to Lesson 3A, Energy Conservation and Transformations. Your objectives for this lesson are to explain the law of conservation of energy and to describe how energy can be transformed and provide examples. This lesson will help you describe how one form of energy can be converted into a different form of energy. We'll also review how to distinguish among the forms of energy and sources of energy. Your notebook questions for today, go ahead and jot them down now. You need to have them answered by the time this lesson is over to be ready for the activity. How do we turn sources of energy into the forms we want to use? Is there such a thing as new energy? Here's a question for you. Let's find out. The law of conservation of energy states energy cannot be created or destroyed. This scientific law states an observation that has been shown to be true in all circumstances we've encountered. There is only one exception. Energy can be created when mass is destroyed. So, the law can technically be corrected to say, energy and mass together are always conserved. But mass is not destroyed in any of the transformations that we will discuss. So, the simpler version is correct for our use. In every problem we work on, energy will not be created or destroyed. Take a note of that box on the bottom. This is very important stuff. New energy is not created under normal circumstances. Instead, any energy that is produced by an activity is simply being transformed from a previous form of energy into a new form. So when you produce electricity, you're just transforming energy that already existed as chemical energy or mechanical energy or solar energy and transforming it into electrical energy. Transformations are the process by which energy changes from one form to another form. Transform literally means changing form. Energy transformation happens in all kinds of familiar ways. Your body transforms the chemical energy found in food to thermal energy and mechanical energy so you can stay warm and move around. Electrical energy from your outlets in your home is transformed to mechanical energy that can move your speakers, which is transformed into sound energy that passes through the air in your room, which is transformed by the nerves in your ear to electrical energy, carrying the signal toward your brain so you can hear it. As you can see from that second example, energy transformations don't just have to happen from one form to another. They can happen in a long chain. Here are some rules for energy transformations. The total amount of energy stays the same through any transformation. Energy can be transformed into multiple different forms of energy. For example, consider the nuclear energy in a nuclear bomb going off. Some of the nuclear energy transforms into thermal energy, heating up the area. Some transforms into radiant energy, giving off a flash of light and other electromagnetic radiation. Some transforms into sound energy as a great banging sound is heard. Some transforms into mechanical energy as objects are pushed away from the area. Another rule for energy transformations: most forms of energy give off some thermal energy during a transformation. If you're trying to get a different form of energy, such as light energy, then the energy transformed into heat is considered lost. For example, when a traditional light bulb, an incandescent light bulb, is powered, it gives off light, but it also gives off lots and lots of heat. The electrical energy coming into the lamp is being used to be transformed into light, which we want, and heat, which in this case we really did not need. Sometimes you'll hear that referred to as energy loss. The energy doesn't disappear, it's just transformed into heat, which is no longer useful for the purpose of lighting your home. So, some transformations can produce electricity. Here are some examples. This is a good place to look at examples because there are many different ways in which we produce the electricity that we use. So these are all examples that could actually be used to power your home right now, probably in some combination of these. Wind energy is mechanical energy, which turns a windmill. So the wind is moving, the moving air has mechanical energy. That turns a windmill. The windmill acts as a turbine. A turbine transforms mechanical energy from moving around into electrical energy. Fossil fuels like coal, oil, and natural gas contain chemical energy. Burning them transforms the chemical energy to heat energy. The heat is used to boil water, which creates steam. Steam flows with mechanical energy, rises up, and it will flow through a pipe if you place a pipe above the boiling water. That flowing steam turns big turbines. The turbines convert mechanical energy to electricity again, which flows through wires to our businesses and homes. Solar panels take light energy from the sun and transform it directly into electrical energy. That's an easy one-step system. Nuclear energy in uranium is converted into thermal energy, which boils water to produce steam. And just like in the fossil fuels example, that steam turns turbines to generate electrical energy. So you can see that if the output, the end result that you want, is electrical energy, you can start with mechanical energy, light energy, nuclear energy, chemical energy, and by building up a system with various steps, you can transform that energy into electrical energy that can be used to power homes. So to sum up, in energy transformations, one form of energy becomes one or more different forms. Energy is not created or destroyed in a transformation. Only the form of the energy changes. And energy transformations are important in the process of generating electricity. Check out Lesson 3B next to find out how you can witness energy transformations in our online lab. Please do not continue to the activity until you've seen Lesson 3B, which explains how to use the lab in detail. Have a great day, everyone.